I want you to think for a minute about how you do your routine daily tasks, something like brushing your teeth. At first, when you were a kid, you had to think about what you were doing. But now, brushing your teeth probably doesn't require much conscious thought. Instead, it's possible to just think, now I'll brush my teeth, and the details seem to take care of themselves. You worked out the process once, and then after that it became routine. Well, this is the whole idea behind functions in computer programs. Instead of a physical task like brush our teeth, we have some computational task like find the average account balance or store the data in a file. We might need to do that task over and over, but we don't want to have to think about the details of how the task occurs every time. We figure out how to do the task once, and then after that we just want to say, do that. Functions are the way we group a set of commands together so that we don't have to think about all the details inside. We've already been using functions. We've imported functions from libraries, like importing square root from CMath. And we've used functions like getLine to get input. And we've used functions for file operations, like open and close, that belong to an fstream. We've used functions that belong to vectors, like pushback, to add to the end. And there have been several more. All of these functions performed some computation for us, all by just making a function call. Well, we're now going to learn how to create our own functions. When we think of a function, the easiest way to consider it is as a so-called black box. We have some program consisting of various instructions. When we want something to happen, we make a function call. We possibly send the function some input parameters. These are the arguments. Then the function takes some action, and possibly there's a final return value sent back to the part of the program that called the function. So, for example, in our program that computed the square root of 2, we had the square root function. We called it passing in an argument of 2.0. The square root function computed the square root and returned a value to us. And that value came back to the program so that it could be output in a cout statement. As far as the inner workings of the function though, that is knowing how the function does what it does, that's hidden from the main program. We didn't worry about how the computer computed the square root. You just know that you passed in a number and you get returned its square root. And on the other hand, when we write a function, we don't have to worry about how it's being used. We might be getting some input parameters, and we might know that we need to return some particular value, but we shouldn't need to worry at all about when and how that function is being called. We don't care about the function's role in the main program, we just need to know that the function is going to do its job. For example, if you imagine being the person writing the square root function, you wouldn't have known all the various programs that would use it, or the multitude of ways that it's being called. You just know, I need to find and return the square root of this number that was given to me. This then brings up the two main reasons that we have functions. First, and most importantly, we have a conceptual separation of ideas. Functions let us write code without worrying about details. Either we're writing a function and not worrying about how it's being called, or we're writing the calling program and we're not worrying about how the function itself works. Second, using functions lets us avoid the work of writing the same code over and over again. So, let's look at how we can actually define a function. That is, how we create our own functions that we're then able to call. As an example, say that we want to write a function that takes in a string and returns how many words the string contains. The first part of the definition is the return type. The return type states what the type of the return value will be. In our example, where we're counting the number of words, we'll want to return an integer. So, the return type would be int. The next part of the definition is the function name. This is the name that we'll use to call the function. We're writing a function that will count words, so word_count seems like a reasonable name for the function. Now, when naming functions, you should take the same care as when naming variables, or even more care. After all, you're naming a black box, So try to use a descriptive, memorable, and consistent name that clearly indicates what the black box does. After the function name, there will be a pair of parentheses, and inside the parentheses will be the parameters. We'll have a lot more to say about parameters, both in this lecture and the next. But for now, the way to think of a parameter is that you need to specify the type of the parameter being passed in and give it a name. So, in our example, we're passing in a string, and we're going to be counting the words in that string. So the parameter is of type string, and it has the name str2count. The part of a function up to this point is called the function header. That is, the function header contains the return type, the name of the function, and the parentheses giving the parameter list. The function header contains all the information needed for the black box of the function to interact with the larger program. Now finally, after the parentheses will be a pair of curly braces. And inside of the curly braces will be the actual instructions for the function. We call this the function body. These are the actual contents of the black box, the commands that run whenever the function is called. For this initial code snippet, I'm not showing any specific commands for the function body right now. But don't worry, we'll spend lots of time inside the black box in this lecture. Let me stop for a second and clear up a little terminology. When we've made function calls, we put values in the parentheses and we call these arguments. These are the values that are given to the function that we want the function to use to do its thing with. As we're now writing our own functions, we'll again have values that are specified in parentheses. But now we call these values parameters. The parameters are directly tied to the arguments. The arguments that we put in parentheses when we call a function match up one-to-one with the parameters that we use inside the function itself. And because the arguments and parameters are linked together so closely, we sometimes use the terms interchangeably. But if we're being careful, arguments will be the values in the function call, and parameters will be the values that come inside the parentheses of the function itself. The term we'll be using for sending in the parameters is called passing. When we transfer a value from the calling side to the function, we say that we're passing in a parameter. Now, we've used functions that take one parameter, or more than one parameter, or even no parameters. The square root function takes one parameter, the number value that we want to find the square root of. The open function that we use for files usually takes two parameters, one string giving the file name, and one string giving the way we want to work with the file. And a function like close doesn't take any parameters. We can specify each situation, one, multiple, or no parameters, in the function header. We've already defined a function, word count, that took a single parameter, a string. If we have multiple parameters, we just separate the parameters with commas. Each of the parameters is defined the same way that an individual parameter would be. Let's say that we want to write a function that counts how many times a particular word appears inside a longer string. In this case, we'd want two parameters. One for the particular string that we're searching for, and the other for the longer string that we're searching in. So, we'd write a function with two parameters, separated by commas. Int, count occurrences, open parenthesis, string str2find, comma, string str2examine, close parenthesis. Any of the names could be different, but notice that each parameter needs both a type and a name. To define a function that has no parameters, we put nothing between the parentheses. Let's say that we have a game where the user is supposed to guess a number, and we want a function that asks a user to enter an integer, gets that integer, and returns it. The function header in this case will be something like int getGuess parentheses. Nothing needs to go inside the parentheses. Now, sometimes we don't need a function to return anything. It just needs to do something on its own and not return a type of any sort. In this case, we can specify a different return type called void. Instead of returning an integer or string or whatever, we say it returns void. For example, imagine that we have a function that we want to use to print out a greeting message. That function wouldn't need to return anything. It would just need to output a few lines of text. Remember that returning a value means that there's a value that replaces the function call. Output is not returned. So, in this case, the function header would just be void print greeting parentheses. The return type is void, and there are no parameters. Okay, let's check how well you're understanding return types. For each of these situations, what would the return type be? First, a function that tells you whether a certain set of measurements indicates danger or not. Well, that function would need to return a Boolean. It's trying to tell whether something is true, there is danger, or not. What about a function that prints out a warning message if there is danger? Well, that would be a void return type. There's nothing to return. The function just outputs some information. Okay, how about a function that computes the recommended dosage of a medicine, given a person's age and weight? Well, that would probably be a float or double return type. It's computing and needs to return a numerical value. And finally, how about a function that will get a person's address by reading it from a file? That would probably be a string return type. The address would need to be returned, and that would likely be in a string variable. Now, let's give you a chance to try writing a function header yourself. Imagine that you want a function to calculate how many days it is until the next leap year day, February 29th. How could you write the function header for such a function? Remember, you need to specify a return type, a function name, and parameters. Okay, let's talk through one possible solution. The problem is about returning a number of days. So which type is that? For days, we should return an integer type. For the function name, we might call it days to leap day. You might call it days to February 29th or something else, but you want it to be descriptive. Then, inside the parentheses, we'll have the parameters. In this case, we need the current date, and we need not just the day and month, but also the year. So we'll list 3 parameters, each of them an integer. And we'll give them names like day, month, and year. So we'll write int day, comma, int month, comma, int year. When a program is compiled, the function definition should occur in the program before the function is actually called. Now typically, functions are defined near the beginning of the file. We write the function definitions, and then later we can make calls to that function. When the compiler comes along and encounters the function call, it sees a function name with some arguments of various types, and it matches that up to the function with that name and those parameters. Actually, it's slightly more complicated. All the compiler really needs to know at first is the function header. In fact, we'll see ways where we can give just the function header information and put the body of the function elsewhere. And this will be useful when we look at creating separate libraries. We'll talk about that in lecture 15. Okay, so now let's go inside the black box and talk about the function body. The body of a function is the set of instructions that we want to follow when the function is called. When you see a function call, you can think of it almost like the commands in the body of the function definition are being stuck into the code right there where the call is. Let's see a really simple example. Let's say that we're going to write a tic-tac-toe program. And let's say that one thing we want to be able to do is print out help for someone who doesn't know the rules. In this case, we can define a function called printHelp to print that information. The function doesn't need any parameters, and it doesn't need to return anything. So the function header will just be void print_help parentheses. Then we can define the body of the function. Inside of the curly braces, we just have a set of cout statements to output the helpful information. We could have put these all in one cout or even in more cout statements if we'd wanted to. Then in the main program, we can make a call to the function by just writing print_help parentheses. When this happens, the text that we had the cout statements gets printed. Within the body of the function, we can declare variables, just like we would in the main program. We can use this variable just like we would use a variable in the main program. In this example, we have a function, howdy10, that prints out howdy 10 times. The thing to notice is that we have a variable I declared inside of the function. What happens here is that the function has its own area of memory, and in that area of memory, a variable named I is created. That variable can be used inside of the function just like any other variable. Now, what about the parameters? Well, each of those also becomes a variable inside of the function's memory. The name in the variable is the name that we used for the parameter, and the variable is initialized with whatever value was given as an argument. In this example, we're going to print out howdy a number of times, but the number will be given by the parameter. The parameter in this case is named n. So, when the function is called, there's a new variable named n created in the function's area of memory. And since this code is calling the function with the argument 10, the variable will be initialized with the value 10. We could say that we have passed 10 into the function as parameter n, or more simply that we passed in 10. Note that the variable I that's declared inside of the function also has a variable created for it, just like before. So that's how values get into a function. But what about values getting returned from functions? This turns out to be really simple. To return a value from a function, the command is just return, and then the value being returned. That's it. As soon as the function encounters the statement return, the function ends, and it returns that value to the main program. In this example, we've written the getGuess body for the header that we defined earlier. This is a function that asks a user for a guess and returns the integer number. Inside of the body, we have a variable named guess, and we prompt the user and read in a guess. Then we return that value, return guess. So in the main program, we can call the function getGuess, and it will return an integer value that we can assign to a variable. In this case, we assign it to a variable firstGuess. When the function is called, the body of the function is executed, and the value is returned. The return command will return as soon as it's encountered. So, if we have multiple lines of code, and we encounter a return statement before we've executed all of them, then we'll just miss some lines. Also, if a function has a void return type, then we can just write return. There's no need for a value to be returned. Or we can even just leave off the return statement if the return type is void. The function just automatically returns at the end. Look at this example. In this case, we've got a silly function, demofunc, that has a void return type. In the function, we print out a line, and then we call return. So this prints a line, and then when the return command is reached, the function ends, and the program returns to the point where the function was called. Even though there was another line of output and another return statement in the function, those lines were never reached since the return was encountered earlier. Let's look at how we would write the first function we talked about, one that counts the number of words in a string. Let's think about how we might implement this. Well, one option is that we could take the string and turn it into a string stream. Then we could read individual strings from the string stream until we reached the end. If we counted how many times we could read in a word from the string stream, that would be the number of words in the original string. So, to implement this, we'll create a string stream, in this case named SS, initialized to the string that was an input parameter, str2count. Then we'll declare two variables. The integer count will keep track of how many words we read in from the string stream. So we initialize it to 0. We'll also create a string variable named word to hold each word that we read. And next, we'll have a loop that continues as long as we haven't reached the end of the string stream. Inside of the loop, we'll read in a new word, and we'll increment count. And this will keep happening as long as the loop's condition is met. That is, until SS has nothing else in it. And finally, we return the count. In the main program, we can call the function wordCount with a string argument, and we'll get back the number of words that are in that string. Now, that wasn't the only way we could have implemented that function. Another option might have been to count the spaces between words. If we can assume that there's just one space in between each word, then the number of words in the string will just be one more than the number of spaces in the string. So, we could have implemented the function that way. We would first declare a count variable and a variable I. Then we'd loop through all the characters of the string one by one, letting I take on the values from 0 to 1 less than the string length. We'd check each character to see if it's a space. That is, we'd take our string, str to count, sub I, and see if it's the space character. And if so, we'll increment count. And finally, we would return count plus 1, remembering that there will be one less space than the number of words. Now, in terms of the main function that calls the word count function, it's exactly the same as before. Now, there's actually a problem with this implementation. If we just count the number of spaces, we'll count extra words when we have double spaces. So we could make a small change to verify that both the character is a space and that the one before it was not a space to fix this. So in this way, if there are a bunch of spaces together, only the first one counts for counting a word. This illustrates one of the main benefits of functions, the conceptual separation. Notice that in the main routine, we didn't need to worry about how the function was written. We just made a call to word count and expected it to give us a result. We could have two totally different implementations of the function, but they'd look exactly the same when they're being called. But we do have to be careful when we write the functions that we don't make hidden assumptions, like the single space between words. That would make the function behave differently than expected. Also, you might have noticed now that our main routine looks a whole lot like a function definition. That's because it is. When we write a program, we're creating a function named main. The compiler actually treats main a lot like any other function at first, but it knows that when we execute the program, we'll be executing the function main. Now notice that main has a return type of integer. That might seem weird. We never actually return a value, but we could. We could return any integer we want from main. Now the main function is special in that the compiler knows to return a value from it even if one's not otherwise returned. If the program runs without difficulty, then the value 0 is returned. That's an indication that there was no error when executing it. If any other value besides 0 is returned, that's taken to indicate that there was an error when executing main. Different return values can indicate different errors. Notice also that the main function doesn't take any input parameters. It's possible to pass parameters to the main function, but this only occurs if running programs from a command line or using operating system specific commands to do so. It tends to be more common among Linux programmers than those programming for a PC or a Mac. Before going further, let's practice writing our own function. See if you can write a function that takes in a vector of integers and returns the largest one. Okay, here's what that might look like. First, for the function header, the function will need to return an integer, so it has a return type of int. Then we have the function name, find largest, and in parentheses we have one parameter, a vector of ints that we give the name v. inside the black box of our function, we'll keep an integer variable named largest that gets initialized to the first element of the vector. Then we loop through all remaining elements of the vector. Our loop starts at element 1 since we already handled element 0, and it continues all the way up to the size of v. If the elements are larger than the largest seen so far, we replace the largest with that value. And finally, we return largest. The findLargest function needs to come before the declaration of the main function. Then, in the main routine, we can call this findLargest function with a vector of integers, and the returned result will be the largest among them. Okay, the last thing to keep in mind when writing your own functions is the idea of scope, which is not only important for functions, but relevant for almost all of programming. When we talk about scope, we're referring to the range of a program in which a variable is defined. If a variable is defined in a part of a program, it's said to be in scope, and if it's not defined in a part of a program, it's said to be out of scope. In the way we've usually been thinking about programs so far, a variable is in scope as soon as it's declared, and it stays that way to the end of the program. You can't use it before you declare it, and once it's declared, it can be used in the rest of the program. But that's not actually the case. In reality, scope works the way we saw when discussing loops. A variable is in scope only within its own section of the program, where a section is denoted by curly braces. In this piece of code, notice that the variable a is declared inside the main body of the main function. So it's in scope throughout main. But we declare a variable b inside the body of a loop. That variable b is in scope only within that body of the loop. And in fact, each iteration of the loop, it generates a whole new variable, since the previous one's scope ends as soon as it reaches the end of the loop. So when we try to print out b from outside the loop, we'll get a compiler error that tells us that the variable is out of scope. Notice that this means that the variables defined in the main routine are not in scope inside the black box of another function that we might create. For example, the code shown here will give an error when compiling. The variable a is defined in the main function, so variable a is in scope there. But when we try to use variable a inside another function, it will be out of scope. Now, one of the nice things about so-called scoping is that we can reuse variable names in different places without causing conflicts. Let's see a simple example to illustrate. In this program, notice that we have a variable balance declared in the main function, used to refer to an account balance. We also have another variable balance declared in the function named calculateLoan, and this time it's referring to a remaining loan balance. What happens here is that we have two separate sections of memory. We have the main function section of memory, and there's a variable there named balance. And also there's a section of memory for calculateLoan, and there's a different variable there, which also happens to have the name balance. When we're in the main routine, any reference to balance will refer to its variable balance. And when we're in calculateLoan, we'll be referring to its variable balance. So, our output statements from the main routine always show that the value of balance is 75, both before and after the function call. Meanwhile, the output statement in calculateLoan shows that the value of balance is 475. There's one topic I want to mention since you might see it, but its use is generally discouraged. You can actually declare variables outside of the main routine. These are called global variables, and they're in scope for the entire program in every function. Now, that said, it's much better practice to do what we've been doing and use what are called local variables. That is, only use variables declared in the current function, and pass information between functions through parameters and return values. That way, you can see exactly what's going into and coming out of a function by looking at the header. Functions are a key part of programming, and we're going to be using them regularly from here on out. They enable us to organize our programs by breaking up ideas into individual pieces, the functions, and they can sometimes save a lot of repeated coding. There's a lot more we can do with functions, and in fact the next lecture will show us some more interesting ways that we can pass parameters in functions. See you then.